Good day everyone, my name is Mr. Adedotun. What we're looking at is what we call heat and temperature. Heat and temperature. What do we mean by heat? Heat can simply be defined as the total internal energy of what? Of substance. Heat is what? Total internal energy of what? Substance. That is heat. It is total internal energy of the substance. Okay? From there, we know that heat can what? Heat is measured in what? In joules, right? Heat is measured in what? In joules. Joules or in what? In calorie. In calorie. Why? Because calorimeter is the name of what? The instrument used to what? Or the apparatus used for what? For measuring what? Heat. Take note. Calorimeter. That's the name of the instrument or apparatus used for measuring what? Quantity of heat. Okay? And we use scale to what? To denote what? To denote heat. Okay? Q or what? Or H. Q or H. We use this to denote heat or this. When you talk about heat, you talk about what? Energy what? Energy difference. Okay? Or temperature what? Temperature difference. And let's say for instance that we have what? A substance at temperature 50 degrees Celsius, and we have another what? Another substance at what? At 20 degrees Celsius. What will happen? There will be what? Higher what? Movement in the molecule of this. Because of what? Because the temperature of these four substances what? Is higher than what? Than the temperature of the second substance. Okay? There will be movement. All movement of what? Of molecules there. Compared to this. And don't forget that it flows from where? From the region of what? Of higher what? Temperature to what? To the cooler region. Hot region. You can see what? Hot region. To what? To what? Cool region. Of course, the temperature of this is higher than this. So there will be what? Movement of what? Of heat. From this to this. Till when? Till the two bodies will what? Will balance. That is the temperature of the two bodies will what? Will be balanced. That is, let's say the first body, that's the first body, the temperature will be like 50 plus this, that's what 70 by 2, that's 35. And the second one also will be what? 30 what? 35 degrees Celsius to balance. Then once it balance, what will happen? There will be what? No movement of what? Of electrons. Okay. So it is what? Is the total what? Total internal energy of what? Substance. The total internal energy. The total internal energy. It is measured in what? In joules. Joules or what? Or calorie. Joules or what? Or calorie. Or calorie. And calorimeter is what? The instrument. Calorimeter is what? The instrument. The instrument used to what? To measure what? To measure heat. Take note. That's the name of the instrument used for what? For measuring heat. Calorimeter. Calorimeter. Okay? And it has symbol of what? Of Q. Q of H. Or capital H and not small h. Okay? Take it. Take it. Calorimeter is an instrument. Okay. Let's move to the next part. We have forms of what? Of heat transfer. Of course. You can have it through what? Energy. 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 And work. Okay? This is mechanical. This is mechanical. Why this is what? Non-mechanical. Non-mechanical. This is mechanical. Why this is non-mechanical? Mechanical. This is in joules. Also in what? In joules. Yes or no? Yes. Energy in joules. Work in what? In joules. That's mechanical. Why this is what? Non-mechanical. Take notes. Mechanical and non-mechanical. That is form of heat transfer. Forms of what? Of heat transfer. Forms of what? Of heat transfer. Forms of heat transfer. Mechanical and non-mechanical. Okay? Let's move to what? Temperature. 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 So temperature is the degree of hotness and coldness of what? Body. Or you can say what? Temperature is the average kinetic energy of each molecule. Temperature is the average kinetic energy. When you say what the kinetic energy, when you say average energy of each molecule, we are referring to it. Yeah, that's why I said it's the total what? Total internal energy. But this is what? Average kinetic energy of each molecule. Let's say for instance that we have this at where 50 degrees Celsius, that's body A. Okay? We have molecule inside, molecule, this, blue, this. Okay? We have another one there. That's B. A, B. We have this. Okay? This is at 20 degrees Celsius. Since the temperature of this is higher than this, there will be what? There will be what? Movement of molecules. These are the molecules. These are the molecules. Are we together? Okay? Because the temperature here is higher than this temperature. What will happen? The molecule here will what? Will move faster. That is, this will move to move this. Okay? But this will just what? Be moving gradually. This. Just because of what? Why? Because of the temperature, 20 degrees Celsius. Okay. That's average kinetic energy of what? Of each molecule. That's temperature. Is average kinetic energy of each molecule. Okay? The next one is thermometry. Thermometry. This is the instrument used to what? Used in measuring temperature. That is thermometry. Like a thermometer. It's an instrument used to what? To measure what? Temperature. This is the instrument used. Or the process of what? Of measuring what? Temperature. We have scales. Scales of what? Of temperature. Scales. Scales. We have scales. Basically, there are 3 scales. We have the Fahrenheit scale, we have the Kelvin scale, and we have what? The Celsius scale. We have the Kelvin scale, Fahrenheit scale, and what? And Celsius what? Scale. Okay? So let's look at what the difference between what? The 3 scales. Okay? This is the Celsius scale. This is the Fahrenheit scale. Why this is what? Kelvin what? Scale. Taking? Fahrenheit scale, Celsius scale, Fahrenheit scale, Kelvin scale. When you talk about what the Fahrenheit scale, we have what? 0 degree. Ranges from 0 degree Celsius to where? To 100 degrees Celsius. From 0 degrees Celsius to 100 degrees Celsius. Okay. Why this is what? 32 Fahrenheit to what? To 212 Fahrenheit. Okay? This is 273.15 Kelvin to where? To 373.15 Kelvin. Okay? This can work. You can use this. Okay? You can convert this from Fahrenheit to Kelvin to Celsius. And this can also be converted from where? From Kelvin to Celsius. And you can also convert it from Celsius to Fahrenheit, or from Celsius to what? To Kelvin. Take note. Take note. Okay? Take it. This is known as the lower phase point. Why these are what? The upper phase point. Take note. Lower phase point to upper phase point. Let's look at what? The graph of Celsius against what? Fahrenheit. The graph of Celsius scale against what? Or versus Fahrenheit. Fahrenheit scale. Fahrenheit scale. Okay? Graph of Celsius versus Fahrenheit scale. This is Fahrenheit versus what? Celsius. Of course, this is the origin. This is F against what? Against C. F against C. This is the origin. That is where what? The vertical and what? And the horizontal axis meet, which is always 0. Take note. At 0 degrees Celsius, what will be the reading of 0 degrees Celsius on what? Fahrenheit scale? That will be 32. This is 0 degree. 0 degrees Celsius to what? 32. This is 32. Okay? This will be 212. That's 212 Fahrenheit. Of Of course, that's what the upper face point. The upper face point. 2, 1, 2. At 0 degrees Celsius, the reading is what? 32 Fahrenheit. That's 32 Fahrenheit. Okay? At 100 degrees Celsius, let's mark this place to be 100. That's 100. At 100 degrees Celsius, at 100 degrees Celsius, at 100 degrees Celsius, the reading is what? 2, 1, 2. 2, 1, 2. 2, 1, 2. 2, 1, 2, 2, 1, 2, 2, 1, 2, 2, 1, 2. Okay? Then join the 2 points together. Join the 2 points. Okay? Join the 2 points together. That's the graph. That's the graph. The graph of Celsius scale against Fahrenheit scale. Against Fahrenheit scale. What can we deduce from here? You can take this point, join this point to this point. Alright? Okay. We want to find what will be the temperature at the middle here. The middle temperature. The middle temperature. And let's call that to what? To be C. The middle temperature. Let's call that to what? To be C. If that is C, it means that you can have this side to be C, so this will be C against what? C and F. That's C and F. Okay? C and F. So, this is, we can call the midpoint of this also to be F. That's F. This is 0. Take it. 0 to 32. That's 0 to 32. 100 to what? To this. Join the 2 points together. And divide it. This is 0. So we can have what? We can have what? This over this equals to what? This over this equals to, we can trace this from here, trace it to this point. Okay? Taking to this point. So from here now, we can have what? C minus 0. That will be C. This. C. That will be C minus 0 over this. This over this. This over this. Take that again. This. That's C minus 0 over what? Over this. That's 100. 100. That 100 minus what? Minus 0 equals to perpendicular by perpendicular. Perpendicular by what? Perpendicular. That's this. That's F minus 32. Because F is what? Is greater than what? Than 32. It increases like this. Increases like this. Okay? That will be F minus 32 upon this. That will be 212 minus 32. C minus 0 is C upon 100. This will be F minus 32 upon what? That will give us 180. Yes or no? Yes. Take it. This will give this 2F5, 2X9. From there we can have C over 5 equals to what? Equals to F minus 32 over what? Over 9. take notes. This is the formula. If you want to convert from degrees Celsius to Fahrenheit or from Fahrenheit to degrees Celsius, take it, take it, take it. Okay? 0 to 32, this 0, that's the origin. 0 to 32. 100 to where? To 212. So 100 degrees Celsius to what? To 212. Then join the 2 points together. By joining the 2 points, mark this point, take it to this point. So we can have this by this by this. This is C minus 0. That's C minus 0. Why? This is what? 100 minus 0. 100 minus 0. Take it. Take it. Equals to perpendicular by perpendicular. Perpendicular by what? By perpendicular. That's F minus 32 over this minus this. Okay? And I will give 180. So minus 2, that's 0. 11. 11 minus 3, that's 9. Sorry, that's 8. Remember that 1 that is 180. This cancel this. Okay? 2 in 10 is 5. 2 in 18 is 9. So that's C over 5 equals to what? F minus what? 32 over what? Over 9. Take it? Take it? That's the formula. Take it? So we can convert this to this or this to this. Okay? So from here now, we can deduce that this is equals to C, that's the midpoint temperature, minus the lower fixed point, that's 0, over the upper fixed point, that is 100, minus the lower fixed point, that's 0, equals to, we can call this to F, and we also call this to what? K. Okay? F is what? That will be F minus, that's the mid reading, minus the what? 32 upon this upon this. That will be 212 minus 32 equals to this minus this. That's K minus what? Minus 273.15 upon 373.15 minus 273.15. Okay, C minus C, that is C upon this minus this is 100 equals to this minus this is minus 32 upon this minus this is 180 equals to this minus this will give us this minus 3 273. Okay, see the same thing. So we can approximate that. So we can leave it like that. Okay, 273 upon this minus this will give you what? That's 100. Okay, that's 100. That's 100. That's 100. Okay, from there we can convert this to this. That is C over what? Over 5 equals to F minus 32 upon 9. That's for this. What about if you want to convert from Celsius to what? To Kelvin. From Celsius to Kelvin. From Celsius to Kelvin. We can equate this to be equal to this. Yes or no? Yes. This is equal to this. At the same time equals to this. So we can have C upon 100 equals to K minus 273 upon what? 100. Chicken. Okay. So we can have C to be equal to K minus 273. Take it. Take it. Take it. Alright. 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 Question 1. Question 1. Convert 27 degrees Celsius to Kelvin to Fahrenheit and what? And Kelvin. Convert 27 degree Fahrenheit to Fahrenheit and what? And Kelvin. Just apply the formula. We have C to be equal to 27 degrees Celsius. 27 degrees Celsius. Okay? Take it. Recall that C upon 5 equals to F minus 32 upon 9. Yes or no? Yes. What's C? C is 27. 27 upon 5 equals to F minus 32 upon what? Upon 9. Okay? So what will this be? This will be what? 5 into bracket F minus 32 equals to 27 times 9. Okay. 27 times 9. That's 27. 9. That's 3 raised to power 3 plus what? Plus 2. That will give us 243. Okay? So from here you can expand 5F minus what? Minus 0, 15 plus 1. That's 160. Okay? Equals to 27 times what? Times 9. So you can have 5F equals to 27 times 9 plus what? Plus 160. Okay? F will be equal to what? 27 times 9 plus 160 divided by what? Divided by 5. Divided by 5. 27 by 9 divided by 5. Divided by 5. Take notes. And that should give us 243. 243 plus what? Plus 160, that's 3, 0, that's 3. That's 303 divided by 5. So your answer will be in what? In Fahrenheit. In Fahrenheit. In Fahrenheit. Then what about this? To what? To Kelvin. To Kelvin. 27 degrees Celsius to what? To Kelvin. To Kelvin. We know that, recall that C equals to K minus 273. C equals to K minus what? Minus 273. So K will be equals to what? C plus 273. That's equals to 27 plus what? Plus 273. So what will be the answer? You add everything together. Adding everything together. So your final answer will be in what? In Kelvin. Will be in Kelvin. Will be in Kelvin. You have to add everything together. What would that be? This is 0, 0. This is 9, 0. That's 3K. 3K. That's 3 Kelvin. 3 Kelvin. That will be the temperature of 27 degrees Celsius to Kelvin. To Kelvin. To Kelvin. Lastly, question 2.
Don't get it.
let's call this to the R. Okay? Same. Find the value of R. Find the value of R. Find the value of R. What will the value of R? This is 5 minus 0 over 100 minus what? Minus 0 equals to, what are they? This will be 2R minus what? 2R minus R over what? Over 3R minus R. Okay? This will be 1 over what? 1 over 20 equals to R over 2R. R over 2R. Okay? Let's call this to be R squared. So that will be R squared. Okay? This should just be what? If this is R, let's call this to be 2. Yeah. 2. Yeah, let's call this to be 2. That will be minus 2. This should be minus what? Minus 2. Okay? And we have what? 2R minus 2 over what? Over 3R minus 2. You can first multiply. So that will give you 1 times 3R minus 2. Okay? Equals what? Equals to 20 into bracket 2R minus 2. This will be 3R minus 2 equals to what? 40R minus 40. Take it? Take it? Take it? So we can have what? Can have 3R minus what? Minus 40R equals to minus 40 plus what? Plus 2. This will give us minus 37R. Minus 37R. Minus 37R minus 30 what? 38. So R will be equal to 38. That's minus 38 upon minus 37. This and this will go. So R will be equal to 38 over 37. And that gives the value of what? The value of R. In summary, we have forms of what? Of heat transfer. Yes, just 2. We have heat and what? And work. Take notes. Okay? Work is in joule, heat is in joule, and work is also in what? Joule. Work is known as what? As mechanical. Mechanical. Why this is known as what? As non-mechanical. The non-mechanical. Take note. That's the difference between heat and work. Okay. They have the same what? The same units. Heat is measured in joules, while this is also measured in what? In joules. Or this in what? In calorie. In calorie. Calorimeter is the instrument used to measure what? Heat. Take note. Calorimeter. It is also measured in what? In calorie. Okay? Mechanical. Why this is non-mechanical? Temperature is the average kinetic energy. Average kinetic energy. In each molecule, average kinetic energy, which is also generally known as the degree of hotness and coldness of a body, okay, of an object. That's general definition. Or you can say it's the average heat, is the average kinetic energy. Average kinetic energy in each molecule. Take notes. Okay? We also look at what? Conversion, the graph of C against what? Against what? Against Fahrenheit. That is Fahrenheit versus what? Versus Celsius. Take notes. Okay, thank you and God bless you.